We have all done it. You sit down, stare at a textbook for 3 hours straight, highlight half the pages, and feel completely exhausted. Then, the next morning, you try to remember what you read, and your mind is completely blank. We assume that mental exhaustion is proof of learning. If you feel tired, you must have absorbed the material. But neuroscience shows a different reality. Burning calories through sheer concentration has almost zero correlation with storing new information. The environments where we first encounter structured education were built for mass processing and compliance. They require students to sit still and passively consume lectures, a format that ignores how human memory actually operates. Staring harder at a page doesn't force the brain to record data. If your study habits conflict with your biological hardwiring, no amount of willpower will save you. Schools and workplaces obsess over the content. They assign chapters, code to write, or formulas to memorize. What they rarely provide is the operating manual for the hardware itself. We are expected to learn without ever being taught the mechanics of learning. Cognitive researchers like Oakley have mapped the brain's electrical activity during the learning process. They've observed that long-term retention isn't a fixed trait you're born with, but the result of specific physical changes to your neural circuitry. When you replace intuitive habits with these evidence-based strategies, you build a structural framework. This system allows you to digest and apply complex subjects in a fraction of the time usually required for mastery. The foundation of this framework relies on a specific biological rhythm. The brain operates using two distinct networks for processing reality, the focused mode and the diffuse mode. You need both, and you need them to alternate. When you sit down to solve a math problem you already know how to do, you use the focused mode. It relies on tight, familiar neural pathways. But if you encounter a completely new concept, that same tight focus becomes a trap. The brain gets stuck running down the same familiar dead ends, creating a mental bottleneck. This diagram outlines two processing maps. Left is the dense clustering of the focused mode. Right is the diffuse mode. You activate this sparse network by stepping away. While you walk or sleep, it subconsciously bounces new information across the brain to find unexpected connections. Stepping away from your desk is not a reward for hard work. The distraction itself is the required biological mechanism for problem solving. Glancing over a highlighted paragraph feels highly productive. It's a comfortable illusion. But to actually record information, you must look away from the page and force yourself to retrieve the concept from memory. That uncomfortable physical strain is active recall. Once you pull that raw data into your working memory, you have to format it. In cognitive science, this structural organizing process is called chunking. Think of isolated facts as scattered puzzle pieces. On their own, they easily slip away. You must identify the underlying pattern to group them logically. As these pieces snap together, they form a unified concept. Now, your brain only has to retrieve one stable block. You can consume hours of video or text, but unless you deliberately force your brain to extract and synthesize those pieces into a cohesive structure, the data simply washes away. This graph maps the forgetting curve, how long your brain holds new information. Without intervention, retention drops at a steep rate until the memory is gone. To interrupt this decay, introduce spaced repetition. Reviewing at increasingly longer intervals forces the brain to reconstruct fading memories. Flashcard algorithms manage intervals automatically. Recalling chunks at the right moment thickens the neural pathway. A fragile dirt road becomes a neural superhighway. This is why an intense 10-hour cram session before an exam fails to produce lasting knowledge. True permanent mastery is achieved through precisely timed, systematic review spread out over days and weeks. Consistently oscillating between focus and rest, actively building chunks, and spacing your reviews actually alters the physical wiring of your brain. This structural adaptation is a biological reality known as neuroplasticity. We frequently internalize academic struggle as a personal limit, but failing to grasp a complex subject usually indicates a lack of cognitive architecture, specific neural connections that haven't been built yet, rather than a lack of intelligence. You don't need a massive lifestyle overhaul to begin laying down this architecture. You only need to establish a minimum viable habit. The next time you sit down to work, pick one specific task and set a timer for 25 minutes. Block out every distraction to isolate your focused mode. When the timer hits 0, step away from the desk and let your mind wander. Refining the way you process information changes the math for every other goal you pursue. When you understand the mechanics of the learning stack, the time required to become proficient in a new discipline, whether that's data science or a foreign language, drops significantly.